Hello? Hello. Today I decided to solve a bit of Project Euler. It was recommended by some people whom I know and whom I don't know. For example, Redivush, I don't know how it's pronounced. But today I registered here. So I read the rules, and unfortunately, it isn't allowed to share my solutions or even share my process of thinking. There is a dedicated forum where it's said, hmm, where is it said? Ah, here it is. There is a forum for each problem, but you can only access it after you have solved it. But sharing the solutions is against the rules. It's said here, and it's really vague. It's not said explicitly. Please do not deny others what you have so richly valued yourself. What they mean here is you really shouldn't share your solutions. This is what is said here. Because that way I will prevent you from real learning, which is an active process. However, the first 100 problems are an exception, so they are allowed. I can explain them to you in any way that I consider appropriate, as long as I don't just provide answers, which I will not. So I believe I will record everything that I solve here, but only 100 problems from the first to 100th will be posted publicly. The other videos will be dormant with restricted access, so you won't see them. Only I will be able to watch these videos. However, for this topic to matter at all, I need at least to solve these 100 problems, which I still haven't. So first of all, we would like to create some project. Let's do it. I will work in Visual Studio. Still, it makes sense to make a CMake file for that. So let's start. First of all, we continue without code and we open a CMake project. Now we need to write something in this file, and actually we will write some CMake configuration, which starts with minimum required version. And we will write something like 3.20 because this is what is installed on my machine. Then we declare our project. I will call it Euler for some reasons. Also standard. 20 and 20. We can add project definitions. Usually I add home. Compile definitions. Okay. D home. Finally, executable. We write here the name of the executable, and since I will be solving the first problem, it will be called like prob 0001. Then we write the list of source files which will be needed to compile this executable. We will store everything in src slash prob 0001.cpp. Okay, now the CMake will be regenerated, and it says that it cannot find source file. This is because we needed to create it. So let's do it. First of all, let's create a folder src, and here we add a C++ file which will be called prob0001. Okay. Now it should work. CMake generation finished. For some reason this failed. No, it didn't fail. Everything's fine. Let's make some dummy thing. Yeah, I need to put the semicolon here. Now it should work, yeah? Yes, it works. Finally, let's try adding some okay. The file is stored here. So let's free open input.txt and output.txt. Now it saves. Do we see actually where it saves it? Yeah, it saved it somewhere here. Okay, but let's open it here. How can I add an existing item? Can I even do it? Show all files. Yeah, now I can do it. And I can add input.txt here. So now we can read something from a file and write it there. Can we? Yeah, finally what I would like to do is to wait, can I remove it? Yeah, it still works. Yeah, it still works, but now without an error. Okay. So is that it? Yeah, that is it. Now let's actually start with some problems. If we list all the natural numbers below 10 that are multiples of 3 and 5, or 5, we get 3, 5, 6, and 9. Their sum is 23. Find the sum of all the multiples of 3 and 5 below 1000. So let's assume that everything should be solved like without a brain, unless we really need to. So in this case, I think that we can derive some sort of a formula, because like we can draw some Venn diagrams and see that there are some multiples of 3, some multiples of 5, some multiples of 15, and we need to find the sum of all these numbers. So we need to find this plus this and minus this. And for each of these things, there is a formula of for summation of arithmetic progression. However, we will not do it. We'll simply run a cycle. Also, one final thing that I would like to do is to add a configuration of release. I can do it like this. Can I? Can't I? Yeah, I think I can. Here it is, and now I can run it in release. Ah, now I will need the other file. Let's look. So what I need now is this folder, and here I will need an input.txt. And output.txt writes this. Okay, let's check it. Haha. Below 1000 means that it should be strictly less than 1000. So already in the first problem, we met some problems. Okay, let's redo it. And now it is a success. This is a new record of our difficulty. Members found to be spoiling problems beyond the first 100 problems will have their accounts locked. This is sad. Okay, let's continue. I'm not really interested in explaining my solution to on the forum. Let's continue by considering. So we consider the Fibonacci sequence. We want to look at the terms whose values do not exceed 4 million and only even valued. We need to sum them up. This can also be done quite brainlessly. So first of all, since this sequence is exponential, this means that sum of several terms is not much larger than the last of these terms. So since the last of the terms is less than 4 million, this means that the sum of even all terms here is not more than like 10 or 15 million, so it's not big. Therefore, we can just do it in an int. Let's start with 1 and 1. So while y is while true, actually, let's do the following. So I say that x equals x plus y and swap x and y. So now x will store the initial value of y and y will store the initial value of x plus y. So we shifted by one position. After that, if y is even, we add it to s. Finally, we say, before that, actually, we say that if y exceeds 4 million, we break. Actually, I don't like to write 4 million like this. Let's do like this instead. Also, I allowed a mistake because I should have created a new project for that. This is not fine. This is not correct way to do it. Instead, I should have... So let's fix my error. First of all, let's create the new project and put our code here. Then here we undo everything we did. And this is set in stone, so we do not touch it anymore. Moreover, I would like to create different input and output files for each problem. So yes, and here we will put 0002. Okay. Also, this thought that we will add this file to this project. However, we will not. Instead, we will create a new project. Okay. So now what we should get here is output 0002.txt and also we need to choose this file here and only what? And only after that we get our answer. Excellent. Okay, we continue. What is that? Boring. Largest prime factor. Largest prime factor. What's the largest prime factor of this number? So this is a factorization problem, and let's start with solving it naively. Which is going until the square root of the number. So what? Let's choose prop 3. So we go through. First of all, why can't I copy this number? Copy to clipboard, tech comments. So I would like to create input.txt file where I store this number. Then I have an output.txt number. Actually, it will be created by its own. So, unfortunately, this is a long number. So we will read it. After that, we just need to go through all numbers from 1 to the square root. And check them. So if n is divisible by I, we say that answer is I, and while true, n divided equals I, if n% I is 0, then break. Nice. In the end, we also need to check if n is greater than ans, then we say that ans is n. And finally, we print the answer. So this is a standard algorithm for going from 1 to the square root of the number. And it works for checking primality. Yeah, but maybe in the end, n is not 1. It happens if, well, it always happens. It happens, I guess, when the maximum prime divisor of n is of power 1. In this case, we just store it in the answer. Okay, let's see. It is 7. Well, is it? Is it just 7? Okay, do we believe this okay, I understand. It should be 0 here. This is a stupid bug. 71. So do we believe in this program which found 71? I think we can print in the CR all the prime divisors to be sure. Why 1? Okay, let's start with 2 because I don't like starting with 1. Yeah, it's just 71 to the power of 7. It is okay. What is the largest prime factor of the number of this number? How did I fail to find out that it's 71? Maybe my copying of LaTeX is a failure. No. it definitely looks like 71 in the 7th power. Oh my god. Am I really unable of writing appropriate code? Okay, this time this worked. Disaster. This is a disaster, yeah. But this time we see that the answer is this number. Okay, next time I will try to solve a problem without an error. Palindromic number reads the same both ways. Largest palindrome made from the product of two-digit numbers is this one. Find the largest palindrome made from the product of two three-digit numbers. Okay, this is a dull problem because it can be done even in Python. Okay, I understand. Actually, it would make sense to write everything in Python so that if our solution is bad, it works slowly. It will work slowly. In this case, it will not work slowly because we have C++, which is blazingly fast, as they say. And this is unfortunate. But I still don't see any reasons to switch to another language. Let's just continue.